Well, hello and welcome to Pyrotech Talks. This is the online seminar series for fireworks professionals and enthusiasts like yourself. Welcome back. It's been a while since we've had a show. We've got an excellent one today. Very good presentation with some very good panelists. We'll get to that in a couple of minutes, but we've got some stuff we need to take care of first. First of all, the legal issues. Everybody knows that fireworks can be dangerous. So with a little bit of education, you can mitigate that danger. So we strongly encourage you to learn what you need to know to stay safe and be sure that you follow all of the local and federal and state regulations. And you must be in full compliance. If you are not, we cannot help you. You're on your own. We strongly encourage you to search out a club such as the PGI or one of your local clubs, WPA, WPAG, FPAG, et cetera, et cetera. And those, of course, are in the United States. Across Europe, I'm not sure exactly what they have. But the bottom line is stay safe, stay legal. All right, so let's introduce our panelists for today. Let's see here. We've got two panelists. First one is Dan Miller. Turns out that Dan Miller joined the PGI in 2012. He also joined Wisconsin Pyrotechnic Arts Guild at the same time and began learning about rockets. Today he's a regular competitor at PGI conventions, primarily in the rocket competitions where he has been very successful. His most recent wins were in 2021, where he took home first place awards for both the best medium rocket and rocket level 4. He is currently the president of WPAG. When he grows up, Dan hopes to become Tom Ravenclaw, and he values every chance to learn directly from the master. As it turns out, Dan's also an excellent interviewer, as you will see here shortly. Welcome to Pyrotech Talks, Dan.
Thanks.
All right, our other panelist today is Ned Gorski. Many of you know him. Ned has been making fireworks as a hobbyist for over 30 years. He enjoys and is widely known for his mastery of a vast variety of fireworks devices. This led to winning the PGI Grandmaster Award in 2006 in Appleton, Wisconsin. Today, Ned is known as the man behind the curtain at fireworking.com, a website dedicated to learning and sharing information about making fireworks. Again, fireworking.com, highly recommend that you join that site if you can. It's an excellent repository for information. Ned has known Tom Rebenklau for about 20 years and greatly admires his creativity, precision, humility, and the variety of effects he produces. Welcome to Pyrotech Talks, Ned.
Hi, everybody. Glad to be here. And,
all right.
Can you see me now?
Oh, yeah.
Okay.
Yep.
Okay, great.
See and hear you. Yep.
All right.
All right. So before I introduce our presenter, Tom Ravenclaw, we want to run a video. And this is a video segment from Past Fire Videos, and we want to thank them for allowing us to use this. And so go ahead and roll that video when you can. And this takes about 2 minutes, roughly.
My name's Tom Rebenklau. It's what I call WTF. Not what the, but it's welcome to fireworks.
96 of the most precision-made rockets in the world. And what a joy that he would take the time to share them with us.
I honestly don't know why I still do this. I'm getting on in age and I'm wondering, like, you know, when's it going to be time to stop? It's just what I do. It's what the hands do when they have nothing else to do. It's just build fireworks, and hopefully people enjoy it. People that come out and help and see what size these are and see what comes out of them, they definitely appreciate what they're seeing.
You're talking hundredths of an inch difference in timing to create the effects that he has. And he's only using a 2 3/4 inch header on them, which is pretty small. But the effects that come out, you'd swear it was coming out of a huge shell.
The pyros understand. Civilians, regular people, they might go nice, but the pyros, they understand.
right. So that was thank you to Past Fire Videos for that. That was an excellent segment there. So now I want to introduce our main guest speaker, Tom Ravenclaw. Tom won the PGI Grandmaster Awards twice, first time in 1986 and again in 1988. He was also awarded the PGI's Max P. Vanderhorck Award of Excellence in 2021. I was there. I think he was floored and surprised by that. Well deserved, though. Tom worked for 33 years as a precision machinist, making specialty tools and small handheld medical instruments. And aside from his talents in pyro, Tom is also an RC airplane master in pylon racing. He did that for about 30 years. Tom claims that he speaks 2 languages fluently, English and micrometer, but I've also heard him practice his mutter a little bit. So anyway, a very warm welcome to Pyrotech Talks. Tom, welcome.
Yes, good morning or good afternoon. It's afternoon here. I'm sure it's good morning someplace else, but thank you for showing up.
All right. Thank you, Tom, and welcome to you and the 2 panelists. So I need to tell everybody out there that a large amount of this presentation was recorded previously at Ozfest back in October, and we'd like to thank the Shannon family for hosting that event. It's a wonderful event. So what we had Dan Miller do an actual interview of Tom, and we recorded it all and edited it down for this presentation. And but obviously Ned, Dan, and Tom are here, so they'll be answering questions, live Q&A, and so that's what that's all about. So with that, I think we're ready to roll the video. Does anybody have any comments or anything they want to add before we go? All right, let's go ahead and roll the video. We'll see you guys for Q&A in about 12 minutes or so.
Hey, Tom. We've got lots of your equipment to show us today, but first I want to ask you, how did you get into fireworks?
I was always interested in fireworks, even from like a little kid, and I lived in New York and couldn't get anything or anything like that. So, you know, I always was interested, and I found out about the PGI, American Fireworks News, and then it spread from there.
About how many years have you been doing this?
I got my first exposure to display fireworks in 1979, when I knew absolutely nothing. I knew nothing about it. I knew nothing what was going up there, and there was a small carnival show, and I ended up, after the show was over, I said to my wife, I says, I'm going to go down there and talk to somebody and see what the hell happens. They're either going to kick me off the field or they're going to talk to me. And I met one gentleman, which I started following around for a lot. He would show me absolutely nothing. Nothing. He wouldn't show me a damn thing. And I spent about a year following that fellow around, and I was about ready to give up because I didn't know anyone else in the trade or the hobby or anything like that. And just by luck, I met somebody else who introduced me to somebody else, much more friendly environment, and then things just spread out from there.
Did you have a particular mentor as you learned to make fireworks?
Well, you go to conventions and start asking questions to like Swishers and Don Rose and stuff like that. And this was long before pyrotechnicas and stuff like anything I would find, any information on fireworks that I could find, any book, anything I would buy, read, and try not to forget what I was reading. But I mean, I got a stack of books at home that's a good collection for somebody.
And you've really become one of those mentors too. You share your knowledge freely, answer anybody's questions. It's really great. You're kind of known for building your own tooling and making highly precise stuff. What did you do for your career that led you into this kind of ability?
I was a machinist, toolmaker by trade, and I grew up running machinery down when we lived in New York, down in the cellar. My father had a couple small lathes and a small bench milling machine, and those are the toys I would play on. That's what I played with, was machinery, and that's kind of like what I know.
No CNC?
No CNC at all. Everything I've always done in all my life has been manual machining. Some of the stuff I did make maybe could have been made on CNC equipment, but everything more or less was onesie, twosie. They give me a project, hey Tom, we need something to do this. Go figure it out. And you'd go over in the corner of the shop and figure something out and do it.
And that's what you've been doing with pyro now, is figuring it out and making your own
Asking
tooling.
questions, yeah. Making my own tooling is a huge advantage, because if I want to try something, I can try it. If I need I want a certain number of stars inside, pumped comets inside a heading, I can make up a pump to do that. You know, it just lends itself. It really does lend itself to be able to make your own tools.
That's excellent. Lately, we've seen you shoot lots of rockets with precision headers. So let's start there. Let's talk about your rocket motor. What fuel do you use for your rocket motors? Is that a whistle fuel? What kind of fuel do you use?
I use black powder, and inside my 1 pounders, I use 58 nitrate, 33 80 mesh charcoal, and 9% sulfur. It's not ball milled or anything like that. It's 58 33 9 is the fuel I use inside of these tubes, which are slightly bigger than a 1/4 inch. 3/4 inch is 750 thousandths. The guy who rolls my tubes has a mandrel that's 795, so it's a little bit oversized. And I have my tubes made 8 inches long, which gives me another 1/2 inch of comp on top of the of length. And I guess if you were into drag racing, you would say those rockets are stroked and bored compared to a normal 1 pounder.
So that's a very specific formula that you use. Do you think if somebody else didn't have your tooling, that formula would work? Or is that, really for this
Probably
tooling?
underpowered.
Underpowered. Yeah, so it seems
You
like
gotta play with it. You have to play with it.
So you have an extra long spindle here, and you have a slightly longer tube also. You have 8 inches on the tube.
I just had another 2000 made. I had made 8 1/8, just so I had a little bit more room on top for when your headings have a convex surface because of the string. Just a little bit more room on top to set the heading. That's all.
And do you make any other types of motors? Is that the?
I just basically do the 1 pounders. And
So what do you like about rocket motors? Why do you use rockets?
it's a different form of lift charge, I guess. It gets it up there. It's different. Something a little bit different. A lot of people make some very nice rockets, but I think I have a pretty good variety of different headings and things like that. And I don't know, it's something different. I used to, back in the 80s, compete at the PGI and stuff like that. I was making 8-inch multi-break shells, but when they started looking too small for me, I said, hey, come back to your senses, Tom, and enough's enough. So I started with, and the heading diameter is 2 7/8, which is an oddball size. Now, the reason I became it at 2 7/8 diameter is because I had the tooling to roll the cases and stuff like that. Why would you have the tooling to do that? Well, if you string and paste 2 7/8 diameter insert, 4 of those would fit nice inside a 7 1/4 inch can, which would be for an 8-inch shell. So that's how I had the tooling for 2 7/8. If I use these motors to lift up a 2 1/2 inch diameter heading, and I'm talking actual size because that's what I need to know to do the mathematics to make my tooling. 2 1/2 inch diameter heading, it's kind of a waste for the motor. And a 3 1/2 inch is kind of like on the heavy side for the motor, depending on what you put in it. 2 7/8 just happen to work out very, very well for what I do.
It sounds like you have it all tuned together. You have a spindle length, a tube length, a black powder formula, the nozzle you're using, and the size of the header, all in balance to make it perform the way you want.
It seems to work reasonably well sometimes.
Does the rocket give you an advantage for these headers over just putting these in a mortar?
Well, it makes a hell of a lot less noise if you shoot them up.
Okay.
I mean,
Does it help with orientation?
yes, you could call these, I do have kind of nicknamed them orientation devices because that's kind of what they do. If you get your timing just right, you can get it so that you're focused on the end of the train, the caboose, and you can see things as opposed to the side of the train. This gives me a little bit more orientation and stuff like that.
That's great. Well, let's get into the details of those headers a bit later. Tom, why don't you show us the tools that you use in building a 1 pound black powder motor?
Well, again, this is a spindle I made, which is a little bit longer than your normal spindle because I have longer tubes. And the tubes are sleeved when I'm pressing them. And I like these tubes here. I have these made up. They're not New England paper tube rock hards, which is pretty hard to get now anyways, but I like these. I wouldn't consider these soft pulpy tubes. I would consider them somewhere between a New England paper tube and a soft pulpy tube because I've seen some tubes that are pretty soft. Those I would call soft pulpy. But what I like about this is it's slightly bigger on the OD, which gives me more of a gluing surface for putting the heading, hot melting the heading on the end. And also when you press, if you can get a good look at this cutaway, you can see how it actually swells. It actually will swell into the cardboard and help lock it in. And you can also see the...
you see each increment there.
When I press, I usually rise 1/2 diameter each time on the pressing. I don't rise the full diameter. I go 1/2 diameter each time just to make sure everything is compacted in there, and I'm used to run 0.5% of moisture in with the fuel, but now I'm running 1% moisture in with the fuel.
Tom, do you wax your tubes?
No, I've never found a need to wax them, so I go by the KISS, K-I-S-S, keep it simple, stupid. If I don't have to do it, I don't bother to do it. I've never found a need to do it, so I just don't. I'm not saying it's right or wrong, it's just in my, from what I am doing, I've never needed to do it. So again, one less step.
Tom, I see a smaller size tooling here. Looks like you're making something smaller lately, and maybe you have a sleeve that goes with this?
Yes, I do.
Let's take a look at this.
I had a bunch of 3/4 inch OD tubes up in the attic, and they were sitting there for, I don't even remember where I got them, so I decided to try something a little bit smaller, just because. And so I made up the tooling for this. This is slightly longer than your standard spindle because I wanted to max out the volume of the tube with propellant, and this is the spindle I came up with. It's sleeved on the outside. You can see it fits, so it's sleeved, and then there's a funnel that goes in on the top of this thing. This funnel, again, this is made out of PVC because it's easy for machine at home. This goes over the top and holds, so you can see what it does.
And so you can put your drift right through that funnel.
Yes. Now the tube does shrink a little teeny bit as you're going, but this is, at home it's a little bit, must have picked up a little, but you can keep it down against the tube because this just, against the sleeve, because this just, it slides a little bit. It works out very, very well.
Tom, I've seen clamshell tube supports, and I've seen collet tube supports. I've never seen a tube like that. How do you use that as a tube support? How do you get your motor back out of that?
Okay, once the motor is pressed in there, it is a little bit difficult to get out. I've got another, it's someplace here, but basically it's a hollow piece of PVC that this will fit into, and you just take, again, it's around here someplace, a dowel, and push it out with a dowel. It will come right out the bottom. It's not really a dowel, but that's the general principle of it. You push it out.
Excellent, Tom. What is this used for?
Okay, this I use to set my timing, which is the distance from the top of the spindle to where you drill through your clay into the delay. The way I use that is this piece of Teflon on here that will slide back and forth. Nope, it's for this one. This will go up. This is used to center in the bottom here, just so it's not flopping around. This I set up in a V block, vertically on my mill, with the distance between the end of the tube is not touching the V block. So I'm referencing off the inside, right here is where I'm referencing. And in the mill, which you could use a drill press, but you set your quill stop, and the mill, for whatever you want for delay, you put size block in there. When your drill comes down, you've set your time. That's how I set my timing. I usually run about a 1/2 inch of timing. Even on these things, I usually run a 1/2 inch. Sometimes I'm down to 475 thousandths between the top of this spindle and where you drill down through the clay to actually hit the delay. I've found that one diameter of delay is way too much for what I'm doing. So, like I said, I'm usually down to about a 1/2 inch, or maybe in some instances I've dropped down a little bit more to 475 thousandths. It's not that critical. It's whatever works for you. I don't want my rockets doing this. I want them doing this, so you can see the end of the train and not the side of the train.
All righty. So that's the first segment of this thing. We are having some technical difficulties with the chat area, and I'm also not seeing any questions typed into Q&A. I was wondering if somebody in the audience could just type something there to see if anybody can say anything at all. There we go. Got a couple. We got a couple tests and they worked. All right. So that's good. I'm not certain what's up with the chat, but we'll keep working on that as best we can.
One thing I know we were going to do was put up a graphic. Tom mentioned the formula he uses in his quote, 1 pound rocket motors. Tom, would you reiterate what that formula is? Because I don't think we can put up the graphic for that formula. I know folks will be interested in that formula.
For the 1 pound is 58% nitrate, 33% AD mesh, 9% charcoal, And I usually, like I said in the video, I used to do a half a percent of water, but now I put in 1% of water. Make sure it's thoroughly mixed within the with the comp. Usually do about 3 motors plus worth of comp. Put it into a bucket with a sponge attached to the top of the bucket. Keep moisture in there, and then I work out of that bucket into another smaller bucket that I actually take the powder out of, while the big bucket is got the sponge on top of it.
Would you
Just to
repeat,
help keep the
would you
moisture.
repeat the percentages of the chemicals again? What were those percentages?
58 nitrate, 3380 mesh, and 9% sulfur.
Yeah, okay. And you're not using any air float charcoal in those motors. You're using all 80 mesh charcoal.
That is correct. The reason I don't use air float is the 80 mesh makes a lot less dust.
Yeah. It also creates a nice spark tail as your motors are going up, which is nice. Yeah. With the clay you are using, we've chatted a few times in the last couple weeks. You're using just powdered bentonite clay, no wax, no grog, no additives other than just a good quality powdered bentonite clay, correct?
Well, I guess I never mentioned it. I do put in 5% toilet bowl wax in with the clay. Just maybe it helps moisture proof it a little bit more. I don't know, but one of the fellas suggested I try 5% toilet bowl wax in with the clay, and that's just what I've been doing because someone suggested it to me.
You do that. We have a question about how you fuse your motors.
Okay, I take a piece of that 5-stranded black match that you would see on shell leaders, and I fold that. Basically, I'm lighting from about 4 inches up inside the motor, and the spindle is about 6 inches long. I'm lighting about 4 inches up. So I have a pacifier that goes right up to the 4-inch part up inside the motor, and that's where I light from.
So you're not lighting right at the bottom of the propellant grain. You're lighting up fairly, at least halfway up, maybe a little farther
About
up.
2/3.
Great.
About 2/3 the way up.
You were talking about your smaller rocket motors. You mentioned that they were 3/4 inch OD. I don't think you mentioned the ID. What is the
Half-inch
ID?
bore, 4 ounce.
And you're using what's the length? So it's a 1/2 inch ID rocket motor. How long is the tube you're using? Is it a standard 5-inch tube?
5-inch long tube. Yep.
Okay.
They're not New England tubes. They're I don't know where I got them, but I've seen these type of tubes a lot of places. It's not the New England rock hards, but it's and it's not soft pulpy either. It's I don't know what to say. It's a decent tube.
Okay, per our conversations, you're also not using the same propellant formula in those 1/2 inch ID motors, which a lot of people would call a 4-ounce motor. You're using a different, a final formula in those smaller motors.
Yes,
And
I am. And I had that yesterday on a piece of paper. I'm looking at my notes right now. Okay, basically 65% nitrate. This is in the 4-ounce 1/2 inch bore. 65 nitrate, 26 80 mesh, and 9% sulfur.
So that's a little higher in the nitrate, a little lower in the charcoal, which result in a slightly more powerful propellant in those smaller motors.
Well, the way we were trying, a friend of mine, Harry Lynch, he had some 1/2 inch, we were fooling around with some 1/2 inch bore rockets, and we're using 631, and he just kept adding nitrate to it until we got to approximately a 15% additional nitrate to the 631. And when you do the math and round off things a little bit, it comes out to the what the hell was it I just gave you? 65.26.9. That's just the way the mathematics worked out.
And your potassium nitrate, like most of us when we're making a rocket propellant, your potassium nitrate is a nice fine mesh potassium
Yeah, I have
nitrate.
to, if I get prills or I get the crystalline, I ball mill it. Yes, that I do.
Well, thank you so much, Tom. We're going to move into our second segment now, and keep typing your questions in that chat, and we'll take more of your questions at the next break.
All right, so this is going to show us how we pass fire from the delay in the motor up to your heading.
This is for the 1 pound. It's not for the 1/2 inch bore over there, but I use thermolite because I was able to get some, and I have it so that the thermolite can slide a little bit inside the pacifier tubing, so that just before I'm ready to glue the thing on, I will make sure that the thermolite is sticking out, and there's a little bit of space in there where the hot melt would go, so that when I put the hot melt on here and put the hot melt on here and push it down together, it will actually touch the delay, and if it's sticking out too much, it will slide in, so it's always touching the delay. You could use black match or something, but this is much more user friendly as far as being. It doesn't black match would just flake off.
So you've drilled back into your delay through your clay.
Yes.
And then you have your thermolite set a little bit long.
Yes.
You fit them together.
Yes.
That delay hits a thermolite and you know they're touching.
Yes.
Make good connection.
Yes.
That's really neat.
Now, normally on my 1 pounders, like I say, I was running about a 1/2 inch of delay or something like that. I'll usually put 6/10 of an inch over the spindle, and then I put my clay in there, and then when I drill back down through the clay into the delay, which is 600 tall, but I'm going for 500, 1/2 inch, the thermolite actually sits into a little pocket of delay to just help make sure that I'm getting fire transfer to the pass fire.
That's great, Tom. Let's look at this tool. We haven't talked about this yet. What do you use this for?
This is basically a drill guide, drill bushing or whatever. It goes over the top of the tube. Outside, you can see how this would go inside like so. I've set my distance from here to here with the drill. And this is just the drill guide that goes back through the clay, just to make sure that the hole is somewhat in the middle and stuff like that. I use the carbide drills for drilling back my delay. Carbide drill, I do it in my mill at low RPM and keep the flutes of the drill clear, so I'm not getting any heat buildup or anything like that. I constantly clean out the flutes. And I do use carbide tooling because, believe it or not, the composition is abrasive, and the carbide tooling just happens to stand up pretty good for me.
Tom, tell us how you choose to attach your motors to your sticks.
Well, I have a little sets the stick in, and then I references off the motor and some hot melt, and I just hot melt it on there, and then after it's been, I clove hitch it on there. I like to put my stick back as far as possible. Just why not put the weight back as far as possible?
So you've attached the stick with some hot melt and 2 clove hitches.
Yep.
Do you have a certain length of the stick that you're worried about?
I've run them short as 36 inches with a light heading and stuff like that, but normally I like to keep them 42, 44 inches long or something like that. It just happens to be a stick length that works out well for me.
And does that make them, balance?
I have no idea. Never balanced a motor in my life. I just put a heading on it, regardless whether it goes from something like this to a taller headings, and I just shoot the thing, and it seems to sometimes work out reasonably somewhat okay.
That's great. Tom, a lot of people would fuse their black powder motors with a little J-hook of Visco. Is that what you're doing too?
No, I don't. I like to, if I can get it, I take the match with the 5 strands in it, I fold it in half, expose a little bit of the end of it, Visco on the other end right here, fold it in half and shove it up as far as how high up I can get the thing. It's about 6 inches long. I'm about 2/3 of the way up there. That's only because that's as far up as I get the match. I like to put your J-hook down the bottom and get your motor so it's right on the edge, J-hooking down the bottom. If somebody else or something slide it up a little bit further and light closer to the top, it could pop the motor. So I put it under the most stress that I possibly can to dial it in and get the motor so it does not blow up. And lighting from the top will do that.
That's fascinating.
And it's also nosed, so that won't come out, and you don't have to have a piece of Visco. Hey, anyone got some Visco? Well, the line of people want to shoot more rockets. It's ready to go. You're up to the line to run the top fuel dragster. You better make sure there's fuel in the tank. They're not going to let you refuel it. It's ready to go.
Very reliable. Well, thanks, Tom. Let's move past motors now. Tom, you have a large pile of scoops. I think I only have 2 scoops. Why do you have so many?
Well, first of all, these scoops are not used. I have a separate collection of scoops for actually putting the fuel inside the motor. But these scoops, I do a lot of pressing inside tubes and multiple pressings and things like that. If one scoop happens to be a little bit too much, I've got a shorter scoop. If it happens to be not enough, I've got a longer scoop. I've made these up out of solid from 250 thousandths to 900 thousandths in 25 thousandths increments. It allows me to fine tune what I'm doing, because on my press, I've got a guide on my press that tells me exactly what's happening inside that tube, so I don't have to worry about it. I know exactly where it is, and you can fine tune the amount of composition you put in by the selection of scoops, and these were machined out of solid.
You must have to take some careful notes to remember which scoop you used for a certain device.
Yes.
Are keeping notes important?
Yeah, especially if you don't forget to read them. which I have done.
Well, let's shift down just a little bit, and this looks like a star plate. Is that right?
Yeah, I use this particular star plate. I made this up myself. I use this particular one for doing my willow stars, where I want the pellets all the same size, or doing my AP strobe, where I want the pellets all the same size, in an attempt to get everything to burn out at once. It's the best I can do, but the bottom line is, this is completely changeable. It was all done coordinates on my mill, but the trick to this thing is this box that goes over the top. Because once you know how much composition it takes to fill the holes, the next one you'll weigh out a little bit more composition, and I use these things here to charge the holes. And it keeps the comp over the holes in the plate by having this box over the top. This is a lifesaver right here. That's the reason for that.
That's neat, Tom. Well, let's move on to comments. I think. You have some insights here. Tell us about what kind of devices you make with those tubes.
Well, again, I don't make my own motor tubes, and I don't make these tubes up here. Just about everything else I have to make my own tubes for. I have a system which I can use my lathe. I just use the lathe to turn the mandrel. I have a foot switch on it because I need two hands to manipulate the gum tape. I made a little platform that goes on the compound of my lathe that allows the gum tape to come out with a sponge over it, get it wet, and roll it up. And I need the foot switch because I need both hands to control the gum tape. And like I say, there's a variety of different tubes that I have to roll, all the way from whatever. Little small tubes, little ones like this, tubes like this. I've got to roll all those things. The neat thing is I also have a method in which to put holes in the side of the tube. If you can take a good close
Those are
shot.
very clean holes.
Yes, they are. They're punched.
Wow.
And here's an application where it might be.
And so you have a time fuse placed in that very clean hole. Looks like some
CA super
glue, some
Yep.
super glue in there.
Yep. Once you learn how to use CA and you got your right clearances and stuff like that, it works out quite well. I've not had a problem using CA. Even though it's brittle, I've built and flown radio control since 1972, and you learn how to use your adhesives and what you can do and what you can't do with them. I've not had any problems using CA for what I do.
How long do you roll your tubes, and how do you cut them to your length?
It's a good question. First of all, I have a system in which the gum tape can come out across my table, and I've got a rule in which I know how long to cut the gum tape. And that's just by trial and error. The ID is not too hard to control because that's the size of the mandrel you're rolling the stuff up on. But the OD I like to control because I'm sleeving these things. And this is a very brittle tube. It's got to be sleeved pretty well so I don't crack the tube. And once I figure out what I want for a length of gum tape to get so many revs so it fits whatever it is I want it to fit, that's how I control it. And believe it or not, when you got things working right, you change the length of that tape an inch one way or the other. It makes all the difference in the world in the OD of this tube and how it will or will not fit down inside the sleeve. So, and also when you're starting to do it, what I have to do is I roll up a few that I think are close, let them dry, see what they're going to do, and then adjust from there if necessary. By adjust, I mean the length of the gum tape.
What adhesive do you have in the bottom of this tube?
Okay, again, everything's oddball. I have to make my own discs and stuff like that. I've got punches and dies to make up all these discs and things. The disc is normally set down about 1/10 of an inch or something like that. And I was using West Systems epoxy. You could use polyester resin, but I'm using West Systems epoxy.
All right, thanks, Tom.
And another thing I do is I have a method of flaring the inside of that tube a little bit. So instead of the wall of the tube coming like this and then square to the end, there's a little bit of a chamfer on there. Why is that chamfer on there? Well, it's a nice place to start the disc. Also, it's more like a rivet head where the epoxy forms like a little rivet head, so to speak, to maybe help from blowing the end disc in. So if you look really close, you can see the chamfer on that side. And it's giving it a rivet head.
Tom, show us some of the finished devices that you use from those tubes.
Well, here's an application here where I make my black powder hummers. This is a little fixture which I use to drill the hole tangentially to the ID of the Hummer. I used to make them with with an 1/8 inch wall, but was having little problems with it cracking, so I dropped it down to a 406, a 406 ID, and a little bit thicker wall. And this goes up in my mill, and this is a little Destaco clamp. The Hummer would go inside. There's a stop there, and this just holds the Hummer inside there, so when you're drilling the hole. And again, drilling with a carbide drill, continually keeping the flutes of the drill clear so you don't get heat. But this is a fixture I use to drill the vent holes in my Hummers, right here.
And what fuel do you use in your Hummers?
I have the fuel, exact ratio of the fuel is in my notes, but it's generically a black powder fuel with a little titanium and toned down with a little bit of 808.
Tom, I see two very different lengths of visco coming out of these Hummers. Tell us about that.
Well, I can fit 10 Hummers per row inside a 2 7/8. I go 3 rows high, which means there's 30 Hummers in there. And rather than have them all go off at once, all that work, I'd like to get a little bit more air time out of the thing. So I generically have a group of 15 that go off, and then there's a slight pause before the second group of 15 go off. And the way I do that is by the length of fuse that I use. One is cut and trimmed very close to the vent hole, and the other one is as long a piece of fuse that I can get on the outside and still have them stack inside the heading and not have them interfere with each other. So that's how I get the different delays on the Hummer, is by the length of the visco that goes in there. It's pretty simple. It's still a trick to get the visco laid down. It's held down with nitrocellulose. I have some little balsa wood fixtures that will actually hold the thing like this, and I paint this with multiple coats of nitrocellulose just to glue that down. And then what I will do is, before I use, the very last thing I do is I'll take a sharp razor blade and slice that end of the visco at an angle, and then I will put the prime on it. But that's the last thing I do to so no powder or anything falls out of it during transportation or whatever. But that's how I achieve the two different timing lengths. It's not perfect, but it still gives you a little bit more air time, and it's different. So something to do, but that's how it's done.
Do you drill the holes for your Hummers before or after they're
No,
filled?
I drill after they're loaded. Again, I'm using a carbide drill, it's low RPM on my mill, and constantly keeping the flutes clean. You're picking at it and flip the end of the drill to get the stuff out of the flutes, and you just peck at it, peck at it. It's not really bad to do. It works quite well, but again, you're cognizant of what you're doing, and make sure your tools are sharp, clear out the flutes, and that's about what I do. I haven't had a problem. Can't say I won't, but I haven't had one yet.
That's great, Tom. I see some other longer inserts here. Tell us about these.
Okay, I have a heading that has what I call delayed whistles. In other words, the heading's got no stars and it opens up and there's nothing. And then out here, then the whistles will start. The way I get the delay is a piece of manator cord that goes over the outside. And it would light from this section here, and would be the delay. The manator cord would burn down and then go through the cross hole, which lights the composition that's just over. It lights the composition. Now, the way I keep these things from starting as soon as the shell opens up is you got to fire from the brake charger to get in here and prematurely light the delay. I mean, there wouldn't be any delay. So I have some F7 felt, inch thick F7 felt. I punch out some little worms. Those worms you push in there, it keeps the fire from getting in, but yet they blow out real easy to keep the whistle from detonating. It works very, very nice. And if you have a whole bunch of collection of those felt worms, you leave a few around somebody's car or something like that, and up on the dash, and they have no idea what the hell's falling out of my car, because these little felt pieces, where do they come from? So it's good for that too.
How about these?
This was a tourbillon, a colored tip tourbillon, where the composition is in here and some pumped stars, hollow, like go-getters in the end. This would get primed, that would get primed. There'd be fuse here, so basically it's a tourbillon with colored tips. Those are the colored tips.
That's great. Tom, tell us about this last device.
This I call a Whirlwind because I found an insert on the ground on a Class C item that was called Whirlwinds of the Caribbean, something like that. And I took a look at how the thing was made. There's a disc, compressed clay in each end here, composition. The hole runs completely through the thing. Here's the delay. It will burn down, hit a piece of thermolite that's in there, and it vents out both ends. But it's basically, it comes out, leaves a glitter tail, stars in the middle, leaves a glitter tail, and then the bottom shot, which would be on top of the report, heading anyways. So it's just something different, another tube item. That disc that goes in the end to keep the fire out of this side. The thickness of that disc made a huge difference, and also you have to have it so it will burn through the disc, because when I first started doing this and getting my delays and stuff right, everything was working fine until I put a disc on the end and found out that it wouldn't transfer fire into the fuel, and I was very surprised. So I had to come up with a way in which to get a disc that when it would burn through the disc, but that keeps the fire from getting in there.
So the device starts by burning from one end, leaving a
pressed
glitter
comet.
tail.
Yeah, glitter tail, yep.
And then we hit a
There's
piece
clay.
of fuse in the middle between two pieces of clay.
Yeah, piece of in this case I'm using Maniticord.
And once we hit that, fire transfers to this end
Both
and
ends.
this end.
It blows out both ends. It blows out both ends. Yes, that's correct.
Show us some of the tools you used to make these inserts.
All right, for my delayed whistles, which is which is this. Obviously, on a whistle, there's a vacancy inside the tube. This little pinhole goes up and puts a hole up into the fuel a little bit. So when this starts off, it not just starts whistling. It makes a very raspy sound and stuff like that. And that's achieved by this pin right here. Now, when I'm pressing these in my press, I don't want to have to switch rammers or anything like that. So I come up with this deal here where you need a hollow rammer, which would go down like this. And then you need a solid rammer. So I come up with a slot in the thing like so, that if you want it hollow, it's like this. If you want it solid, it goes over like that, and then the rammer is solid, so you don't have to change anything. It's a piece of carbon fiber as a shear pin. That's what this is, a piece of carbon fiber for a shear pin. So if you forget to do it, it will shear the carbon fiber. But that's two rammers in one. There's a solid one, and there's a hollow one. And it gets locked over like so.
I see the advantage of being able to make your own tooling.
It helps. Okay, this here, okay, when I do my cross headings like this, there's a shot, a handmade firecracker that goes down in the middle between, here we go, right here. This handmade firecracker that goes in there, which is this right here. Again, I roll my own tubes, punch my own discs. It's held in with super glue. I will super glue one end, put it in a mandrel on the lathe, drill the fuse hole in it, then fill it, put the thermolite in there, fill it up, and put the disc on the other end. This is what's used to roll the shots. It's a piece of stainless. I roll it up on this. You can't pull the tube off by itself, but this is a stripper. That just helps pull the tube off the end of this thing. But it's done by hand, no machine work, by a gum tape. But this is the stripper that pulls it off. So I get my little tubes, which someplace around here have a little empty tube, but generically you can, if you get a close-up of this, you can see, is this an empty tube? Yeah, here's an empty tube right here with a hole in one end.
Tom, you said these little shots have thermolite in them.
Yes.
Tell us about thermolite.
Well, the thermolite's pretty hard to find now, but I locked in a lifetime supply of it years ago, which when people ask me about thermolite, I says, you can have it all after I'm dead, because I won't share that with anybody because I can't get any more of it. But what I'm looking for in the thermolite, particularly where I'm using it inside my cross sets themselves, inside the actual cross set, I'm looking for some sort of device that has a uniform burn rate, as opposed to a piece of black match or something where it's going pss, pss, pss. This gives a uniform burn rate. I've used both fast, medium, and slow thermolite internally inside the cross sets, and they all work. But I normally use fast because I have it. I also made a cutter to cut the thermolite because I know personally know two people that were cutting thermolite with a pair of diagonals, fast thermolite, had to go off on them. So I made a cutter that actually will cut the thermolite, which has 4 wires on the OD. And if you use a plier or something like that, it just splays the wire out. You can't do nothing with it. This cutter right here, it's tool steel, around what I had, piece of 01, piece of A2, which I had to work with when I did my own heat treatment stuff. But basically, as you can see, there's a hole there for the big hole I just put in there for whatever reason. But there's a hole there and there's a hole right there. When it's over like this, the holes line up. When you pull this lever like so, it does that type of thing. It's just basically, I know that one of these is in use in a factory in New York, and they've cut thousands and thousands and thousands of pieces of thermolite. They've never had a problem with the thing sparking off on them or anything like that. But again, this is all hardened tool steel. You don't want to make that out of aluminum or anodized. It's tool steel. Surface ground nice and flat, and that's the principle behind it. 2 holes that line up to go like that. It's basic stuff. It's just you have to do it, that's all.
A machine shop helps.
Well, it does help.
Tom, you said that your delayed whistle has a piece of manager cord.
Yes.
What is manager cord?
It's something that burns at a uniform rate. I have no idea what it's used for commercially, but it was available and I was able to get some. It's similar to thermolite, but not quite the same. But it's what I use for the delay down the outside because it's a uniform burn rate, and it's just what I use. What it's used for commercially, I have no idea. But that's what it looks like. It's kind of tricky because when I super glue the CA this down to the outside of the tube, but this has got a plastic sheath on it, which really does not stick too well to the super glue. So after it's super glued in place, I will then take a piece of masking tape and make sure it's adhered down over it, and make sure these little folds here are sealed up with super glue so I don't get any fire in that direction. So it only takes fire from one end here, which would be primed, and burns. There's your delay, and crossing the tube onto the whistle comp, and that's what gives me the nothing happens, and then they light. This is how it's done right here. I suppose you could use Visco, anything you want to use, but I happen to have this, and that's what I use.
All right, we're going to break here for another Q&A session. Dan, you were going to say something.
Yeah, I see one hand raised, or a couple hands raised now. Please go ahead and enter your questions in the Q&A chat. We want to make sure that all the questions are documented and that we choose only the questions that are appropriate to the segment we're on now. Thanks very much.
One question I'm seeing, Tom, is you said you recently bought a batch of your quote 1 pound, which are little oversized tubes. What's your source for those tubes?
There's a place in Avon, Massachusetts, Marshall. I'd have to check on, there used to be Marshall Paper Tube, and that's where I have them made up. They used to be down in Fall River, Mass. Then they moved back into Avon, and that's where I had them made. I can get the exact information. I had troubles getting tubes made. When I brought first batch, they made them the wrong dimensions, even though I brought down the sleeve that they go in. I brought down the old tubes that they were to make them to, and it sat down and explained in detail exactly what I needed and why I needed it. And the first batch came through. I don't know, but they finally did correct the situation. I've got a nice set of tubes now that will work for me.
Gotcha. You mentioned drilling into your rocket comp when you're dialing in your delay amount. You mentioned some other drilling that you do. When I'm personally tutoring someone, I'm emphasizing minimizing exposure. When you're doing that drilling, I'm assuming you don't have a tub of composition over here or a tray of
Doesn't
stars.
make sense. Doesn't make sense to do something like that.
Yeah. You really minimize exposure. Safety is our #1 rule, as anybody who makes fireworks, going back to the rocket motors, you do a lot of custom work in terms of your tooling. Even your tubes for your quote 1 pound motors are not standard stocked size tubes. But stepping back to the 1/2-inch ID tubes, we chatted about this a little bit previously. You're using a 5-inch tube, a 1/2-inch ID, that's a standard size tube. Your tooling, though, custom made by you, That spindle is a little different than a stock spindle. You and I were comparing those, and your spindle is a 1/2 inch longer. And the way you accomplish that is the bottom shoulder that the tube sits around is shorter than standard. Mention how you sort of dialed in getting that 4-inch spindle in there, but still having enough room for your delay and your clay above at the end of top end of the motor.
Okay, what exactly is the question?
The question is, your spindle, the tapered portion of your spindle in your 1/2 inch ID motor tooling is a 1/2 inch longer than a standard spindle. If I wanted that spindle, I could go to Caleb at woodiesrocks.com and he would make that spindle for me. The diameter at the base is the same as stock tooling, and it's essentially the same at the tip, but it's a 1/2 inch longer. In order to have enough delay composition over that spindle and then a clay bulkhead, you had to do something slightly different at the very bottom of that spindle, right? You shortened up your shoulder.
Well, if you're talking about where the nozzle starts inside the tube, where the nozzle starts, I've moved the nozzle back as far as I could and still have a little bit of the nozzle starts about 1/10 of an inch in from the end of the tube. So I've moved that whole nozzle back a little bit, which gives me more room on top of the spindle. And as far as the overall length of the spindle, I just drew out on my print a 5-inch long tube, and I knew I probably wanted about a 1/2 inch of delay, and then I needed something for clay and stuff like that. So that determined how long I could make the spindle. It was strictly by the length of the tube and what I wanted for delay and a little bit of clay over it. It designed itself.
And similar to your 3/4 inch or slightly 0.8 inch ID motors, you're using about a 1/2 inch of delay over your spindle.
It's in that range, yes. I have gone as high as 600 thousandths on certain things, and I've dropped it back a little bit. But generically, I've dropped it back to 475 on some of them. But generically, a 1/2 inch is what I'm running. Whether I'm using 39 as the delay, or if I'm doing a rocket that has a charcoal theme, such as a willow or a charcoal croisette, I will use the fuel as the delay. On the 1/2 inch bore ones, I've tried both using 39 as the delay and the charcoal as the delay. They both work. They both work at about a 1/2 inch, but I like on those small ones, believe it or not, I like the charcoal fuel used as the delay. It just seems like that charcoal tail on that particular motor works out very, very well, just leaving it all charcoal. And the delay, when I say a charcoal delay, that is the fuel.
The same propellant all the way up to your bulkhead.
Exactly. It's not a different charcoal formula. It is the same propellant, both on the 1/2 inch bore and on the 3/4 inch bore, the 1-pounders.
Now, we did have a question come in about what your glitter delay is. You're mentioning 39. You mean Winokur 39 glitter, one of Winokur's formulas, right?
Yeah, I gave it to you yesterday, and honest to God, I had that piece of paper in this room where I'm sitting right now this morning, and I put it someplace where everything else I lose, including my glasses, car keys, and hearing aids. I don't know where it ended up. But it's you had it.
Let me cut in right there for a brief second. We are because we're having some trouble with the chat, we can't cut and paste that kind of information in there like we had intended to. We were going to publish all of the formulas and some other details like that, so you guys could do a cut and paste, the audience. Obviously that's not working, so we can't. So what we will do instead is, if you want some of this information,
it's on Ned's site.
Yeah, it's on Ned's site, which I highly recommend, fireworking.com. Best $50 you'll ever spend for fireworks. The other possibility is to get this information directly from seminars at westernpyro.org. Seminars at westernpyro.org. That email address will come up on the very last slide of the show, so you can get a chance to grab it from there. A couple more questions, then we need to move along again.
Yeah, Mike, just very quickly, if somebody will ask the question on that, I'll paste it in as the answer as a question. I can do that.
Great.
Good point. Yeah, look at that. That's why he's the boss.
I have one more question for Tom that I think a lot of rocket makers will have is, we've covered your propellant, your clay. We discussed a little bit the other day how much pressure you're putting on your propellant and your motors. You're using a pneumatic press, and we did a little bit of calculating, and on both your 1/2-inch ID motors and your 0.8-inch ID motors, you are applying approximately 5,500 pounds per square inch pressure on that composition. And that's important. I think that's an important detail for anybody trying to make rocket motors like you make in those tubes. Would be about 5,500 PSI pressure on the composition. That's what we kind of came up with, right, Tom?
It sounds okay to me. Normally I just set my air pressure. The cylinder I have mounted on top of my drill press that I use for doing all my pneumatic pressing, it's got an equivalent of a 22 square inch piston. And on the 1-pounders, I put about 115 to 120 pounds of air pressure on that piston. And on the 1/2-inch bore ones, I put 50 pounds of air.
And we did a little calculating, and both of those, you're right at between 5,000 and 5,500 PSI on the composition, which is a detail most rocket makers want to know.
I'm trying to find that 39 formula. I can run down and get it, but
That's okay. Don't.
all right.
Yeah, let's
I
move
had,
along.
believe me, I had all that stuff on that piece of paper and it's hiding with my glasses someplace.
We have a few other questions that have come in the chat. First of all, have you ever experimented with nozzleless BP motors? Do you have any opinion on nozzled versus nozzleless BP motors?
Yeah, a few years ago, I tried some nozzleless using commercial airflow charcoal, 75, 15, 10. And I think it was Ned at the time was talking, adding 2% mineral oil to tone it down. I think that's what it was with some solvent, and just using the commercial airflow. I'll tell you something. They went pretty good. I have no complaints with them at all. It's just I kind of use the ones with the nozzles on them most of the time because that's what I do. I do have a couple of them nozzleless, and maybe someday I'll get back into just for the hell of it, just making some more nozzleless motors. But they did work, no question about it.
Okay, thanks, Tom. Do you have you use the CA or super glue quite a bit? Do you have a favorite brand, and do you use a gel or a thin super glue?
Primarily, I'm using the thin CA. Occasionally, I'll have a use for the Thixotropic or the thicker CA, but most of the time it's the thin CA. And hobby shops, you go on the Tower Hobbies, places like that. You go on the internet and you'll find, but it's the thin CA.
Okay, Tom, in your colored reports, how thick are you making those tube walls? How are you confining it just enough to give a nice sound on those colored reports, but not too much so that it washes out?
Well, as far as the washing out, I don't know if it would or would not wash out the color, but I tried dialing in the colored report composition so it would work in cap plugs, which is a very small amount of powder, and it also is not like a big stout cardboard tube or anything like that. And I had things working. I had that stuff working pretty damn good. And I went to a couple of shoots in the PGI convention, and wouldn't you know, that green formula gave me the WTF. And I got a little frustrated with it, so I put it on the back burner because I've got other things I have to do. But usually I use as much confinement as I can get, and I roll my own tubes bigger tubes out of gum tape. And I don't know how I can answer that question, but the best confinement you can get on the colored flash.
Hey, Mike,
All right.
real quick, we found the problem with the chat, and the chat should be open now.
Oh, sweet. Nice. All right. We'll give it a try. We've got a couple people with their hands up. So I think you want to ask a question. We can't hear you. So what you need to do is go over to the Q&A tab, which is in the bottom row someplace, and type in your question. Let's catch two more things. One, Charlie's asking, first of all, Tom, thank you for sharing. Given the unavailability of thermolite and Manitor cord, what are your best alternatives at this time?
That's an excellent question. I have not had to research that because I have the availability of the thermolite and the Manitor cord. So I cannot truthfully answer that question because I have it. I've never bothered to research, but I am looking for something that burns at a uniform rate.
I think the answer might be your Visco, and possibly you'll have to passivate it a bit more.
I got found some, must be in inch, it's about 60,000, so it must be 1.5 mm visco. That would probably work out pretty good. But again, I've never really had to go that route because I have the stuff that I use, so I never really pursued what else.
Okay, we've already crossed an hour here, so let's two shout outs, one to Nigeria. That's our first African attendee as far as I'm aware, and another one from Australia. So welcome everybody. And let's move into the third and final segment. That way we get through all of our pre-recorded material, and the Q&A at the end can go as long as people are willing to stay.
That's neat, quite a variety of tube inserts that you use in your headings. Let's talk about some of the inserts that you use that aren't made of tubes. Maybe we can start here.
Okay, I make an insert I call a cavity star. You guys would know them as go-getters, but that terminology was taken. So basically, it's a pumped pellet with a cavity in it. So there's a star with a cavity in it, so I call them cavity stars. The outside and end gets sealed up just like you would do a cross set. And in this case, it takes fire from this end, and the hole helps propel things and stuff like that. I can also use the same tooling for what I call jetting stars. It's basically the same thing, except it's done in reverse. There is some black match that gets glued in there. There's no question about it. There's black match that gets glued in. But when I use a jetting star, well, I mean the star will come out and burn and then jet. Use the same tooling, but use it in reverse. Instead of lighting from this end, which lights the cavity instantly, you light from this end, pasted like a cross set, that burns down, then hits the cavity, and then takes off. So it's using the same tooling to do two things.
Tom, show us what tools you use to make those stars.
All right, well, I came up with this pump right here that it's Teflon on the outside. The reason I use Teflon is because with these I primarily use red gum and alcohol, and there is a little bit of that red gum alcohol mixture that wants to come up around the outside of the pump. But this Teflon, once you've pumped out a couple of them, it just expands out a little bit to help seal to make a seal between the plunger and the ID of the tube, and it just helps. The Teflon just helps do that. If you look inside here real carefully, you'll see that this is sleeved back with stainless steel. I made so many of these things, and the comp being abrasive, that the inside of this, where the action actually takes place, started to wear out. So rather than make a whole new one of these, I bought it out and sleeved it down with stainless.
Does Teflon come as a solid stock like a bar?
You get anything you want. Now, another trick about this is once you've pumped your cavity star, jetting star, whatever you want to call it, it's pretty soft, and pulling it off the pin can be a problem unless you're very, very careful. So there's one way to get rid of that problem, is you just pull out the pin. So that's how this is come up with. You can see what this is. You just pull out the pin. Now you don't have a problem. The thing falls right off. So again, it designs itself. You have too much trouble pulling it off, well, get rid of the problem. And there's the problem gone. So that's the theory behind that. And the Teflon really does help. It does not eliminate every bit of moisture of red gum alcohol solution that might get up here, but it sure helps minimize it. You still have to keep it clean, still have to stay on top of it, but it helps. The way I can check the burn time on these things, which would be the distance from the fire receiving end to the bottom of the cavity, I made up a little thing where I glued a ball bearing on the end, so I can actually goes down to the bottom of the cavity, and you can see the ball bearing and that radius. So I can actually measure with a set of mics, and I can measure out what that distance is between the fire receiving end and the hole. It's done with just mic over it, or vernier calipers or whatever. I mean, it's pretty simple deal, but still, there's a way you can control it.
Sounds like precision's pretty important. Are these some of the tools that you use for measuring these things?
Well, I mean, use normal machine shop tools and stuff like that. I've got a mill at home, and I've got a small lathe. I really miss the the tool making, surgical instrument making shop that I worked in, where I had access to everything. Closets full of diamond wheels, all kinds of carbide, silver soldering, all my own tool steel heat treatment. I don't have that anymore because I'm retired, and that company is now gone. I sure wish I had the ability to go back to that place and do work that I need to get done for myself. But I got most of it done while I was at work, and it takes me a long time to do things at home because I don't have the equipment to do things right, but I still whittle through things and do the best I can to do with what I've got to work with.
Tom, I see something that looks like a comet pump, but it looks like it's square stars. How are you making square stars with a comet pump, and why are you doing that?
Well, you have limited room to work in here, and when you get a close-up this, you can see these are stacked up against the wall, being a little bit smaller in this dimension, this quarter-inch dimension, than if you were pumping out pellets. It gives me a little bit more room inside of here to put colored stars, where these little chiclets would be the outside color, colored stars would be in the middle, and the brake charge stays down in the middle. It's one turn. Always leave one turn of 30-pound baggie goes in there. It holds my brake charge right in the middle, keeps it from migrating any place, and it's just what I do. But that stays in there, and so that's the theory behind that. But to come up with that, I made up this pump. Actually, I made two of these. The first one was out of brass, and I wore that thing out. I cut the tip back where the abrasion was taking place, shortened the pump, used that section of brass, wore that out. So I figured, okay, the next time you do it, make one out of stainless. This one happens to be stainless. And again, it's got Teflon tip on it. It slides in here very, very nice, but after you use it a couple times, the Teflon just upsets just a little bit to form a little bit better seal, which helps keep the gunk from getting along this section of the, but that's basically it. I will set a block in here that I will charge it, and then I will press it. Then this little piece comes over here, and then I trim the end off and eject. And I have a little 2-inch air cylinder set up similar to this, a V-block. It's a V-block that you put it into, goes underneath the air cylinder, and I've got a little 2-inch air cylinder that I use to pump out these pellets and these pellets.
And I assume that you made those a very specific size to fit into the headings that you use.
Yes and no. When I first started pumping out 1/2-inch diameter pellets, a 1/2 inch long, and doing some test headings, they burned way too long. So I knew someplace between the volume of the pumped star and nothing, someplace in there was the ideal volume of chemicals to do what I want to do. And I just worked out something that it's 400 thousandths by 400 by 250 before prime. That just happens to work out and stack well inside of here. If I was to do these bigger, there's no way I would do something like this. I would absolutely use star plate and pump out things. It's a lot easier to use a star plate. You could do a lot more than once. I just used it so I get a little bit more room inside here to put a little bit more central color stars in there. That's the reason for that. And it's unique, it's different. One thing about these, it is a son of a gun to prime these things. You're doing round stars or something, all you have is tangent points hitting each other. With this here, you've got to get the star wet enough all over the place so it will pick up a uniform thickness of primer all over it, and you got 6 flat sides that want to stick to each other. It is a son of a gun to get it just on that edge of being able to have the thing totally coated so it'll pick up prime all over and not having them stick together. It's a trick, believe you me. It's not. You got to stay on top of it. Another reason I would use stuff off a star plate.
This looks like another example where you worked to maximize the room in your device and put as much content in as you could.
Well, it's just another way of doing, yeah, sure, why not?
Tom, what burst charge do you use in a shell like that?
Well, normally my central core is 5/8 inch in diameter, the length of whatever the heading happens to be. I use commercial 4FA powder. I've used GoEx and I've used the Wano, and I augment that anywhere between 0 and 5 grams of flash, the flash being 70-30, Chinese perchlorate and US bronze 809, not blackheaded. I'm using 809. It depends on what you're doing. Generically, I normally add 1.5 grams to whatever volume of 4FA goes in there. It's a gram, but I have go up to 5.
So 4FA fills that whole void? other than the
No,
flashback?
this-
Oh, just the
it-
flashback,
it-
okay.
Fills the dime wrapper.
So what's in the space between the wrapper and the
Stars.
stars?
Different colored stars.
There's no pulverone with the stars?
You can sprinkle a little bit in there. I mean, I do sprinkle a little bit in there to help dirty things up inside, maybe throw a little bit more spit or something like that to help light the primer on the stars. Yes, I will sprinkle a little pulverone in there, but it's not like a lot of pulverone. It's just enough to dirty it up inside, hopefully get a dirty flame to splat a little bit more against the stars and get them to light.
It's great, Tom.
And that baggie does stay in there because, like I said, it keeps everything in the middle while you're making the heading, while you're transporting it or whatever. It just works.
All right, and we're back. All right, so we got quite a few more questions there. Let's see. I'll ask Tom one of them here. Let's see. S. Ray would like to know, what is your favorite chlorine donor?
Well, it depends on what you're doing. I mean, I've got access to, I use a lot of Parlon and stuff like that, but the one that's hard to get that I use in my blue is HCB. That's pretty good chlorine donor, but I mean, whatever you would use, I've used PVC, depends on the formula. I really don't make up a whole bunch of formulas myself. There's tons of published ones out there that are all excellent. Ned's got a whole bunch of beautiful ones on his website. Go with those. They're already proven out. He's done a lot of testing with burn times, and go with what Ned's doing for his N1 or his N formulas.
Yeah,
That's what I would do.
those NX formulas, I'm specifying a Saran in there. Fireworks Cookbook has a pretty good stock of Saran last time I looked. I use a lot of Saran.
Yep.
I have that too. It just, whatever the formula might call for, I most likely have a chlorine donor for it.
Tom, when you are trimming your stars after pressing or your comets, how are you avoiding damaging the ends?
Well, it depends on the side of the star. I mean, if I'm doing something, if I'm doing something larger, I usually have a trimmer that goes over the end, but normally what I do is I have a razor blade a single-edged razor blade that I've dulled up the cutting edge and then went over to a buffing wheel and polished it very, very well. So it will actually slide across the end of the pump. It slides across real nice, and that shaves the stuff off. It goes back that's on small stuff. On larger things like crossettes, I have carbide trimmers, which they're sitting down here on the floor, but I've got trimmers that I made up that specifically do that for a particular size pump. It's like a pepper mill. It's like a pepper mill. You trim the end off, it goes back into the comp nice and fluffed up, and it's very easy to do.
We show a very good demonstration of the use of that thing in 3 weeks from now. We're going to cover that.
Looking at your headings, Tom, I'm not sure that I recall anywhere in the presentation that I watched earlier on the complete presentation that you discussed your spiking. What string are you using? What sort of spacing in your spiking are you using? Or is it coated? Are you coating your spiking with wheat paste?
Most of the time the string comes out, it's wet with wheat paste or at least water, because when you're going over the edge of the heading and you're not going straight down the side, you're going at an angle because you've got to go around the report that's on top. Having that string wet helps it bite into the corner of that case so it doesn't slip while you're pulling it down vertically. Pyrosupplies.com, I use their 6-ply domestic. It's nice stuff. It takes up paste well. It's what I've been using for a while. I can get it. And as far as the spacing goes, I use 24. I made little templates that I marked the end of the heading before I string it, so I get my verticals on nice. And I chose 24 because the index head that I use on the mill to actually make the little template that actually marks the end of the disc has got a 24-hole plate in it. And basically, I'll be honest with you, when you look at it with 24 vertical strings on that size heading, it looks right. I mean, 16 would look too sparse, and I don't know what you put over that, but I mean, the 24 just looks right. So it's 24 verticals, horizontal square for the most part, and string wet. So when I'm going down over the corner of the case at an angle, because I've just come off going around the report, it keeps the string from slipping off the little mark that I put on the end of the heading.
Great, thanks.
The 24 just came up because my index head my index head in the shop has got 24 hole plate, and it just worked out very, very well. I could have done anything I wanted, but it worked out okay and seems to work.
And that's, you're just applying one single strand of that string per every 24 verticals around there. It's just not doubled or anything. It's just one
Nope.
single strand.
Just one.
And Tom, is that flax string?
It's their domestic 6-ply domestic. I believe they call it flax,
Thanks.
but it's their domestic.
Okay.
I'll tell you something. When I was running low on string and I couldn't find where the hell Pyro Supply's information was, where I could call them up, I went all over the internet trying to find where's the phone number so I could call them and get some more string. And I'll tell you, there's a lot of people out there, believe it or not, we're using some of their string making bows, for bow and arrows, making bows. I was quite surprised.
Yeah, Joel has asked for you to repeat the source for that string. That's pyrosupplies.com.
.com. Yep,
Yep. Gotcha.
they're in Florida.
Mhm.
I think Russ Birch is still running the place. I believe he is.
Yeah, I recently got some wax coated linen
Yep.
string from
Oh,
them.
yeah.
They're still selling string, yeah, and hot glue and some other
Mhm.
supplies. Yeah.
They've got a nice supply of stuff.
Mhm. The hot glue you use, I don't know that that's specified anywhere in the presentation. Are you using a special kind of hot glue?
What fits into the hot glue gun,
Okay,
nothing special.
okay.
Special in that it fits. Tom, there, somebody asked to see your pneumatic press. Is that still sitting there close by where you can pick
Yes,
it
it
up?
is.
and-
This is
to,
going to be fun
yeah.
because I tried
right.
doing this the other day on a run to, we're talking the small one now, the one I use on the bench. Now I'm gonna try and hold this thing up so you guys can see it in front of the microphone, but basically
Yeah,
2-inch cylinder up top. Is this the one we're talking about?
Yes, that's it. You might want to actually pull it back just a bit so it focuses better. There we go.
Our 2-inch cylinder on the top. I've got a regulator mounted up here. Some clipped valves. There's a push button. I'm having troubles with, there's a push button right here. You can see how that works. And this switch up here, when the push button is out, I can either have this in the up position, or there are times I will use it where I want in the down position and then push the button to raise it up and take the piece out. But that's it. Can you see that now?
Yeah, we can see that.
Yeah.
And
Now,
We
that's the smaller cylinder you were talking about ejecting stars with. That's not the press you're pressing rocket
No,
motors
no,
with.
no, no. This is used for any pump that I have that has a 3/4 inch outside diameter of the pump.
So a comet
Regardless what
pump, star pump.
Whatever the idea of the pump is irregardless. It's for a 3/4 inch OD pump.
Mhm.
This is the pump. This is what I use. Sit there one at a time for weeks at a time, just doing stuff. It's boring, I'll tell you, but that's what I use. And this
You have
works
enough
very,
for-
very nice. You can put it on the bench in front of you. There's a little V block here that I made up out of some maple that I had laying around. You can see the V block.
Hmm.
The pump goes up in here, and I use a piece of you can easily use 3/8 aluminum. I also work on glass. I have a little 2-inch square piece of 3/4 inch, 3/8 thick glass that goes under here, and I push on that surface. And but this is trying to do this for you guys.
Yeah. I know the machinists and tool makers will be absolutely inspired by you, Tom. There's a private joke between you and me where I go, I'm never going to make my own tooling, and you always go, Ned, get a lathe, get a lathe. Making tools and the precision and the diversity, the variety of tools you make for yourself, it seems like half the battle in accomplishing the variety of effects you make.
I would totally agree with that. I don't know how I would do a lot of things if I didn't have a tool to do it. It's unfortunate that everyone doesn't have a lathe and a mill they at their disposal, but I mean, I'm certainly going to use the tools because that's what I did for a living. I'm not, I mean, it does help tremendously being able to make my own stuff. Not that anybody else, any machine work I do or have been done on with fireworks, any competent machinist could do it. There is no black magic to it. It's all basic machine work. What you have to supply your machinist friend is the dimensions of what you want, because he's not going to know. A 3/4 inch pump, what the hell is that? A well pump? They would have no idea. So you have to supply the design of what you want. That's where the thing is, designing it. Any competent machinist could do anything I do. There is no black magic to this stuff. It's all basic machine work.
That's key. You competent machinist. That would explain why my stuff looks like crap.
Well, it really helped when I was working in the surgical instrument tool making shop, because I had access to that whole place. And boy, I tell you, it was really nice to have the sun and hone for finishing off the inside diameter of sleeves. For me to do that on my lathe now, with the way in which I have to do it to actually get the ID, good finish, straight, no bell mouth, just get it right. It's very, very difficult for me to do it now as compared to having the sun and hone, that was the cat's meow to do that thing. I'll tell you, that was nice. That was nice. I missed that hone.
In your rocket headings, you talked about using a dime bag to hold your 4FA. What's the diameter of that dime bag?
It's a 5/8, 1 turn to 30 pounds, 5/8 in diameter, as long as it has to be to go from end disc to end disc.
And Tom, you talked about jetting stars earlier, which are similar to go-getters. What advice would you have on people who are trying to make go-getters, but they're underperforming? They're a little lazy. How did you get your jetting stars to perform so well?
Well, for a while, I was using some magnesium I had that was -200 mesh magnesium that I got a whole bunch of years ago. But for the ones you saw in on that particular video, I was experimenting around with some of August's 100-hour milled stuff, and that gave it a little bit more zip. You can, like with my AP strobes, there was only one time I found magnesium that would work out of the container, and I saved that for one particular strobe. Other than that, and that's gone now. Other than that, I've always had to take the magnesiums I have available to me and blend coarser and finer particles to get the strobe rate right. I'm sure you can do the exact same thing with magnesium fueled stars. I mean, I know you can. You just have to choose different whatever you have to work with. But what you saw in that video was August's 100-hour milled magnesium. I don't know if he's doing that anymore or not. And there's no way in hell I'm going to start milling magnesiums and magnesiums. I will let someone else do that, and I will purchase it from them. I'm not going to start with that stuff. No way.
The length of the little spindle you're using in your cavity stars would also enable you to adjust the power of the
absolutely.
The star. Yeah.
That's a good point. It's variable.
All right, let's do one more question here, and then we probably need to take our bows. How are you priming your colored stars in your headings, Tom? What different methods are you using?
Okay, basically, whether it's either cut stars or my pump stars, I'm using it's a pulverone formula that they were using up in Telstar Display up in Jaffrey, New Hampshire. It's basically a black powder, heavy charcoal black powder. I don't have that with me. If you write that down next time we do this thing, I will get the exact formula. There's 3 formulas in one of the Pyrotechnicas on pulverone. Basically, I found them all to be a charcoal heavy black powder. And I know that you're supposed to scratch mix is good enough for prime, but in my case, where if I'm cutting a star and I cut a star that's a 1/4 inch cube before prime, that is a large star for me because you can't fit many of those inside the heading. So basically what I do is I usually cut my stars a little bit smaller before prime. And in this case, I ball mill the prime. Why do you ball mill the prime? Because I have a 40 mesh screen that I made. It's on a 5-inch bottom of a 5-inch coffee can with a 40 mesh screen in the bottom. You can put that ball milled stuff in there. And when I cut on glass, before you want to cut your slab and lay it on the glass, you just shake this thing and it makes a beautiful, nice layer of black snow that comes down. Nice uniform surface. It's in thickness. There's no lumps in it. It works very, very well. And I use that same thing for when I'm applying the prime to the cut stars, which I kind of diaper on. I use that 40 mesh that just flows down so nice over the stars, as opposed to taking your hand or a spoon and throwing it on there. That works beautifully. I don't know if that's answered the question. The formula I have downstairs, I could run and get it, but I think you might want to put that on your Q&A for next time, or I'll run down and get it.
No, well, I think you're right. I think we need to put it into our next segment. Speaking of which, we probably need to think about exiting here. Ned, Dan, is there anything else you'd like to bring up or mention?
Not from my end. I thought it was a very good conversation and a lot of my questions were answered.
Yep, come back to the next session. We'll have another video and a lot more Q&A.
Do you know how many people are watching this thing? Is there a people meter on your end?
Yeah, we peaked at about 94.
94 was the limit. Yep.
Yep.
Which is a record for Pyrotech Talk. So be proud of yourself.
Yes. All right. Very good. So, Tom C., if you could move us into that next segment. So thank you, Dan. Thank you, Ned. And thank you, Tom. We really appreciate you guys showing up for this. I want to point out to everybody, this was part 1. And part 2 will air in 3 weeks from today. That's December, 10th, I think. Yes.
On the calendar.
Yep, December 10th, we will come back with the second half of this interview. Once again, we pre-recorded a lot of this at Ozfest in October. Again, thank you to the Shannon family for hosting that event. Thank you to Pacifier Videos for allowing us to use their video segment. That really helped out a lot. And as you might guess, producing a seminar series like this doesn't happen just automatically. And it takes way more than the people that you've seen and heard on the screen here. As you can see on this screen, there are a lot of people behind the curtain that do a lot of different things. So if you run into any of these people in your travels, thank them for what they do, and certainly tell us what you like and what you would like to see improved, and more importantly, what seminars you would like us to try to line up. We're always looking for new, interesting stuff to present to you. After all, you guys are the consumers. If we don't keep you happy, we're out of business. Actually, we do this. Go ahead, Tom.
I'd like to add something to what Mike said. We did some rehearsals on this, and I'll tell you something. The photography they did at Ozfest, and they had the board that the hands that you clap for when the video starts and stuff like that. It was like, oh my goodness, they have put in a tremendous amount of work behind the scenes. They deserve the credit. I just sat here. Those are the ones that with Jimmy behind me. You guys,
well, thank you, Tom.
Phenomenal job, absolute phenomenal job on unbelievable the amount of work behind the scenes.
Thank you, Tom. That's very generous of you. Yeah, we do our best to make it look like we know what we're doing. Sometimes we actually succeed. Let's see. So thank you, gentlemen, for being panelists and presenters. Let's see. Who have I missed here? Move to the next slide, if you would there, Mr. Calderwood. And of course, we are sponsored by the Pyrotechnics Guild International and the Western Pyrotechnic Association. I highly recommend both organizations if you can. If WPA is out of your geographic reach, there are other regional clubs in your area. The WPAG, for example, FPAG, there are many of them. Let's see, and upcoming events, we've got part 2 of this particular presentation on December 10th, same time slot. Please show up to that one if you can. And in February, the WPA does our big convention. We call it Western Winter Blast. It's in Lake Havasu, Arizona, runs for 4 days. It's a great way to get out of the winter and come down to the desert in Arizona for a few days. We'd love to see any and all of you down there. So, and I think with that, I believe we're pretty much done. Thank you, everyone, for showing up. Thank you to all the presenters.
Civilians, regular people, they might go nice, but the pyros, they understand.
Now, Mike, are we staying online here while everyone else goes, or are we supposed to continue to talk, or what?
About another 5 or 10 seconds, and this whole thing will just magically disappear. All right, guys, thank you so much. And,
thank you. I mean, you guys did the work. I mean, it was phenomenal. I hope that it all came out well.
We could not have done it without you. Thank you for your generous donation of time and effort.
Thank you, everybody. Again, we couldn't have done it without all you guys together. And Dan, you're a savior. Thank you,
everybody.
Bye.
Okay, have a good day.